W. Moore, and welcome to Learning Synthesis with Pure Data, lesson number 7. In this lesson, we're going to make our synthesizer into a smoothly playing monophonic synthesizer. There's a few things that we can do to touch it up to make it perform in a more friendly fashion. Also, there's a couple bug fixes that I want to address. So, without further ado, let's get to patching. Okay, so we're starting off on my learning page as usual. I just wanted to point something out here with lesson 6, which is this lesson right here, the previous lesson. I did put a note here that I corrected a bug in the download file, so this file's fine. But in this lesson, I was going to kind of like explain it a little bit at the beginning of the lesson. So that's what we're going to do now. I'm going to minimize my browser, and where we're at is here. This is the lesson 7 folder. Here's the lesson 7 files. Pretty much all the files will outwardly look the same as lesson 6 files. Everything's the same files names, and you open the modules patch and it has all the sub patches in it. In case anybody's wondering why there's like some lines here, these are patch cables patching the modules together. When they're in a patch like this, patch cables aren't hidden. But when we're done with the whole thing, we're going to basically make a parent patch that loads modules inside of it, which means all patch cables will be hidden. It'll look the same, except you won't see the patch cables and everything will be nice and clean. But since we're going to be adding more modules, I'm not going to do that just yet. So anyway, I'm going to zoom in here, and there we go. Here's our patch thus far, and basically it looks the same as lesson 6, but let me show you what the issue was with the lesson 6 files. There wasn't really a problem with the content of the lesson. It was just something I forgot to do, and something else that happened by some strange fluke of nature. So anyway, I'm going to open the ADSR module. This is what the lesson was about primarily. And basically, the one mistake I made is I forgot to hook up the load bang to the duration number box here. This is the overall possible duration of your envelope, and then these are like a percentage of how much of this. Well, it's not the overall duration. It's kind of like like when it's 1,000, meaning 1,000 milliseconds, 1 second. These are the percentages of 1 second that each segment will be. So this is something where you can kind of basically expand the use of these sliders to get, longer, slower segments of your filter and or basically your envelope, and or shorter ones without the sliders being really long or without the sliders having useless resolution. Basically, this is a way of kind of like giving you more flexibility. But since I didn't have it hooked up to load bang at the end of that lesson, and I had intended to, I just forgot to do it, this duration number didn't get sent into here when the patch opens. So when you open the patch, it sounds like there's no envelope at all, basically because the duration wasn't sent through. And by putting load bang on it, it bangs it through. The duration's range is set to 1,000 to 5,000 milliseconds, and so when it opens up, it's automatically set to the minimum. So when this gets banged through, everything's based on 1 second, and that's how it starts. At least you'll hear the envelope, and then you can adjust things from there. It's good that when your patch opens that things sound like they're working. I mean, the patch would have worked kind of, but the thing is it wasn't set that way to begin with. So anyway, let me also go into the submodule. There was one other issue, and I don't know how this happened, but basically here in the submodule, right here where the duration comes through, this number box had properties of a range of minimum 0, maximum 0, which meant that anything coming through would end up being a 0 no matter what. And I don't know how that happened. That's not how number boxes are by default, and I certainly didn't set it that way. Or if I did, I must have really been, I don't know. But it just was wrong. And so I fixed that too. So the lesson 6 download works fine. And in the content of the lesson, I don't tell you to do any of these things, so the content of the lesson's fine too. But in any case, let's get on to the lesson 7 material. Let's actually play this thing so you can hear it. I'm going to go to the media menu and go to MIDI Settings. You got to do this just about every time with PD Vanilla. You got to tell it that your input, in this case, is the SL Mark II. But you got to tell it what your input is unless it's the very first one in your list of MIDI devices. Although sometimes, I know when I teach these lessons on Macs, somehow they default to none all the time, so you got to set it all the time anyway there. And then I'm making sure my speakers are my headset that I'm using. Good. Okay, so now it's working. I just played my keyboard, as you could hear, and it has the envelope intact. And now that I'm playing faster notes, you'll hear it's gliding to each note more smoothly. I already made the lesson 7 updates, and what I'm going to do now is just explain them to you so you can see how they work. You don't see anything on the surface, but basically what I gave it was a smoother monophonic control. So we're going to go into the MIDI section here, open the sub patch, and what I want to show you is I made a sub patch up here. Originally there was a note in object, and the note in distributes note, velocity, and channel. It's still kind of the same way, except I put some extra patching in here to give it better monophonic control. And so in here, what we have is the note in object, and I'm just going to follow these one at a time. Basically, the note value comes in here to strip note along with the velocity value. And what that does is it gives the note value plus velocity, but it takes away all note off messages. So basically what I'm able to do then is send that straight out as your note value. And then, well, actually it strips the velocity messages, forget it. So it sends that out as just your note value, and then it also sends the note value over here to the select object, and we'll see how that works in a moment. But it takes note and velocity in, it just removes velocity. And then over here, actually, let me double check that. I'm just using it to only use note, but yeah, it does just take off the note off messages as I originally thought. But basically, when you send it out and don't unpack it to get the two messages, the note and velocity, you pretty much receive the one, which is just note, and that's how I'm using it. But basically, it takes off your note off messages. So basically, note comes out whenever it's on. Whenever note off signals come through, they're blocked. So it doesn't send the note again for note off. So basically what's coming out of here, out of this sub patch, is just your note messages whenever the note's pressed. But when it's released, the note number doesn't come through again. And same thing over here with this select box. But now what the next thing is, the channel outlet here just goes straight out this outlet, so we don't even need to worry about that in our little mess here. But what we have here is a trigger bang float that's hooked up to the note outlet. And what it does is it whenever a note's sent, this trigger will bang out this outlet, and the velocity is hooked up to this float box. So whenever a note is sent, it bangs this float box and sends the velocity out. And then out here is, in this float box, it sends out what the note number is. So the velocity is in this float box, and when it gets banged, like a note is played, it goes through a select object here. And the select object's default value or creation argument is 0. And that means whenever a 0 is received, or velocity is 0, meaning the note was released, it bangs this float box here. And this float box is containing the note number from this patch here. So when the note comes through, it bangs the velocity through. And then if the velocity is 0, it bangs this float box with the note number. If it's not 0, then it sends whatever value it is out this outlet, which goes down in the outlet. So basically what's happening is your velocity of things that are not 0 automatically go out. Things that are 0 bang the note number here to this one that I have a creation argument of -1. And that's mostly just to say, all right, by default, -1 isn't going to come through. But at this point, whenever strip note receives a note on message, note and velocity on, it basically puts the note number here. So then that means that the select is looking for this note number. And remember, the note number was stored here. So when it gets banged out here, it runs it through select, and if it matches the one through strip note, then it bangs a 0. That basically means that since the note number is stored here, and if the velocity is 0, it bangs it out here. Basically, it's checking to make sure that the note that is being sent, that 0 only gets sent out as your velocity when both the note here and here match, meaning that the note on matches the note being played or coming through. Now here's where the note comes through even if it is velocity 0. Here where it's only non-zero, or the note is being played. So when the note's being played, only then does it send it out here. In other words, this strip note, its last number sent will be the note being played. And here, it may come through with a velocity of 0, but it's only going to send out a 0 if that was the last note turned on. Because sometimes when you're playing the keyboard and you're kind of playing fast and stuff, maybe it'll get a release of a note or a note off message because you're hitting two keys at once, and it's only going to play the note off if it was the last note pressed. So let's say you just are playing quickly like that, and say, like if I'm on the C key, let me find it, here we go, and I go up C, D, E, kind of quick like that, maybe I go up to the D key, press it, and release it before the C key's released, because maybe sometimes you're playing real quick and you're a little sloppy and stuff. You don't want the note, or maybe you're releasing the C key while you're still holding the D key. You don't want the note off message from C coming through because you're already on the D key. And since we're a monophonic synthesizer at this point, playing one note at a time, you don't want, here I'm holding C, now I'm playing D, now C, D, now I'm releasing C, and you hear nothing. Okay, the reason why you heard nothing is because by the time I'm on D, I want to ignore the first notes note off message, because it's just me, playing through these notes fast or something, and I don't want a release of a note that was like before the note I'm playing coming through, because it'll just interrupt the note that's coming through. So by comparing strip note, which takes out the note off messages or velocity zero messages, and comparing it with the note that that just came through that may have a velocity of zero, or in this case, because of the select zero, it does have a velocity of zero. If they're not the same note, it doesn't come through. Basically, the zero only comes out if the last note that was pressed on is the note being released. So it basically edits out all the notes being released that were not the note that you just last pressed. Because since it's a monophonic synthesizer, it can only play one note at a time. So as soon as I press C and then D, that wasn't C and D, hold on here. It doesn't matter if I'm still holding down C. As soon as I hit D, it goes to that note. So in that case, since you're just playing one note at a time and stuff on a monophonic synth, you want to get rid of any of those note off messages from keys you release after. That way you can kind of like, here I'm going to hold down all 5 fingers, and it just goes C, D, F, G, because it's releasing C, D, E, and F automatically because there's only one oscillator. And so when you have a monophonic synth, you want to put in this little extra protection, so that way if you release some other notes in a glissando or you're playing fast and stuff, you don't want the note off messages coming through unless it's the note that was last pressed. That's basically the whole idea. That's something that can interrupt any of your passages that you're playing if you're not playing super accurate. And in some cases, the whole idea with monophonic synth is you're playing melodically, one note at a time. That's what they're designed for. And you want that freedom of being able to kind of like slide through notes quicker and have things bend from one note to another, like go from C to D and E and so forth, and not have them separated or chopped up. Now, one other thing I added as extra protection here is in the ADSR, we're going to go into the sub patch here where the actual envelope is. And here's our attack, decay, sustain, release. This was all explained in lesson 6 when we put it together. But you remember, I put something here that when, for example, this is the note off here. When velocity 0 comes through, this 0 is not only sent to release to 0 because it's time to close off the note over the release time, it also zeroes out a spigot object right here, turning it off. So basically, this can't keep feeding the delay segment. Let's say you play a short note and the note's ending before the attack segment's finished and before the delay happens. Well, if you're releasing then, you don't need the delay segment to come in and ruin the fact that you're trying to play a short note. You want it to just go off and skip. Oops. You just want it to go off and just skip that segment. So that's why that spigot closes. But for another note to be played next, where note on is happening and a velocity that's above 0 is coming through, we need to turn those spigots on, and that's why I have this trigger here with a couple bangs and a float. Basically, the first bang here opens the spigots, and then you have a very short delay of 10 milliseconds, which is barely perceptible, before it executes the note. Basically, here it stores the note number, but it delays this bang by 10 milliseconds. It sends the note number here and begins processing it for the rest of the envelope. So that's the whole idea there. It was just to get rid of that decay segment from, messing up your short releases. But over here, I added another thing to this whole trigger list. I just basically moved these over and added a second bang here Now this doesn't go through the delay, so this happens at the same time that the spigots are being opened to receive the attack, decay, and so forth. Basically, it's zeroing things out over 10 milliseconds. And 10 milliseconds is the amount of time it's waiting before the new note comes in. And it's really quick. It's a really short amount of time, barely perceptible. And so the reason why I have this going to 0 is so that way, let's say you have a longer release time, but a new note on comes in before this note's been released. Well, this is going to cut it off. This is going to go to 0 over 10 milliseconds and allow that new note to start. That way, when you're playing fast things and stuff like that, and let's say you have a longer release time on stuff, you don't want that release time to be dragging on out when you're trying to play another note. It'll sound weird because a new note will sound, but the release time of the old note will be there interfering. For example, let me increase my attack time here. Why did I say attack time? It's the exact opposite, my release time. Alright, so I'm increasing it, so you hear. Now I'm just playing a short note here, finger-wise. But you see there's a bit of a slower fade out to it. And that's because I increased the release time. Now, let me play through these notes quick again. Basically, if I didn't have that in there, the release time of the previous notes wouldn't allow me to go to the next notes so quickly and start the envelope again. Basically, you would hear a slow fade out of the new notes being played as that was going on, and basically you'd be sending mixed messages to the whole envelope. So let me open this again and I'll just compare it. Sorry, open this. And so let's go here to this thing and just disconnect it. So now this message doesn't go to line at all, so it's not affecting anything. And now I'm going to play it again with this longer attack time. It kind of slurs together in a way. You know, and then I heard a little bit of a distortion there because some notes were piling up on each other. Basically, that's because it's not cutting anything off. And you want it to really cut things off as you're going from note to note, so that way there you go. So that way the amplitude of the new notes being played doesn't get piled on. You don't have multiple segments of an envelope fighting with one another, in other words. You want, when your new note's being played, for it to really be going into the attack segment and not going through the release and the attack at the same time. Because basically this line object would be receiving both numbers and they'd be going in kind of opposite directions, which is why it sounded so slurred before when I disconnected this. But in any case, there we go. That's a little bit of the stuff that goes on behind the scenes when you're developing synth software, or it'd be the same thing with analog hardware software, except to be done by electronic components. You need to put in those things that allow for human, in some cases human error, in some cases it's like human expressiveness, so that things will sound the best based on what you're wanting to play. Okay, so that's basically it for this lesson. I'm keeping the lesson shorter now, and we'll see you in lesson 8 for pitch bend. So, thank you for watching the tutorial, and as usual, Crafty has something he wants to say. He says, smack that like button.